right mic. What mic? It's recording sound. Your final is a common final with the 20-1s, right? Which we do in order to standardize your mark. So like if you average the same as them or lower than them, then you're getting nothing added to your marks. Obviously you know nothing better than they do. So your final will include sequences and series, right? Which is from 10.
Wait, do we get our formula? Of course you do.
What?
Do we get our formulas?
No formulas. Don't be silly. Of course you get formulas. Don't be... Okay, so line classification. If we look at the line classification worksheet, you will see that, I mean, if we're in two space and you have lines, right, in other words, in a plane, they can be parallel, or they can be intersecting, or they can be coincident, right? There's one on top of the other, or parallel, or intersecting where they meet at only one place. When we go into three space, then we can have lines that are parallel, coincident, intersecting, or we can have skew lines. And skew lines are lines that don't meet, but are not parallel. Okay, in other words, I got a line here, and I got a line passing underneath it here. Right? Those are skew lines. They don't meet, but they are, and they're not parallel to each other. All right, so what does it say here? Skew lines are any lines which are neither parallel nor intersecting. If the lines are parallel, the angle between them is 0. If the lines are intersecting, the angle between them is 0 as shown. And if the lines are skewed, there is still an angle that one line makes with the other. And if we translate one line to intersect the other, the angle between the original lines is defined as the angle between the intersecting lines.
Wait.
Right? So in other words, we can move this line down until they intersect and then work out the angle between them. Yes?
It's not 0 for it.
It's theta.
Oh, is it
Yeah,
theta?
you said 0.
I'm sorry. My ability to resolve, yes, with my eyes. If the intersecting, there's an angle between them, theta as shown. Right, theta as shown. You can translate. Yeah. The lines, it's supposed to be parallel. Okay, so line classification. Lines may be parallel. Intersecting. Or skew. So I'm going to give you a couple of lines. We'll look at a couple of lines and we will answer something about them. So here, line 1 has equations. Line 1 has equations. X is equal to -1 plus 2t. Just don't like writing ones. -1 plus 2t. Y is equal to 1 minus 2t. And Z is equal to 1 plus 4t. Line 2 has equations. X is equal to 1 minus u. Y is equal to u.
Because it can't be t.
Can't be t, it's a different line. And Z is equal to 3 minus 2u. Okay? So those are the equations for our two lines, which are obviously in 3 space. Right? So we got an X, a Y, and a Z. So line 1 is XYZ, which is equal to -1, 1, 1 plus t times 2, -2, 4. Okay? Yeah? And line 2 is XYZ is equal to 1, 0, 3 plus u, -1, 1, -2. Okay, so give you a moment, write that out, look at it and say, yeah, okay, I see where you got all that stuff from.
Yeah.
Okay, good. What can we say about line 1 and line 2?
They're in 3 space.
They're in 3 space. What else? Are they parallel, intersecting, or skew?
I like guess skew, but that's probably wrong. How about we solve it and not guess?
What if I said this?
They're intersecting.
True or not true? What kind of lines are they? Parallel.
Oh, we're done. Looks very similar to Friday's. Yeah, we're not Friday.
Okay, so if the direction of line 1 and line 2 are scalar multiples of each other, then they are parallel. Right? So remember, the 2, -2, 4 is the direction of line 1. Okay, remember they're lines too, right? They're not vectors, right? Lines, arrows on both ends. Parametric equation of a line, so a line extends both directions, right? Has that. Since simply you make the t negatives if you want to go the other way, right? I mean, if we say, okay, 2, so that's 2 in the x direction, and then -2, which would be, say, into the board, and then 4 up, right? That's the direction of that line, right? You just plot that point. You plot this point, it's left 1, and then into the board, or out of the board, I guess, and then down, okay? But if you take a multiple of that, if we multiply that times -2, we get that. Okay. So they're in the same direction, and these lines are parallel. If I put a variable in here, then to make them parallel, you would have to figure out what value of x would I need here in order for these lines to be parallel, right? So in other words, to make this here some scalar multiple of this, if there's a variable there, then I would have to calculate that variable. Okay? And you can do that. That's easy enough. Okay, let's take a look at intersecting lines.
I know guess that this is
So let's say that line 1 is equal to r, which is equal to 1, -2, 4, plus, I forget what letter that is. What letter is that? Is that a lambda or something? Lambda. Oh, and it's on my shirt. Lambda.
That's a half-life symbol.
See,
Get it right.
Got the lambda going on here. And line 2, L2. 17, 4, 5. 6, 4, 7. What's this?
Mu.
What? Do these look the same to you?
Yes, you do. Mu.
This goes a long way towards explaining things. Like your need for glasses might be right up there.
For new glasses. New glasses.
Okay.
Mu glasses.
So here's the question. Do the lines intersect? And if so, what are the coordinates of the point of intersection?
I'm going to say yes, they intersect.
So how do we find out if things intersect? You set them equal to each other and see if you can solve. If you can solve, then they intersect. If you can't solve, then they don't intersect. Okay? So that's what we're going to do. We're just going to set them equal to each other and see if there is in fact a point of intersection, right? So is there some value of lambda and mu such that these lines intersect? Okay? Can we in fact find that? So we are going to go 1, -2, 4. Equals 6, 4, 7. Okay, So we want to solve this and see if there is a value or values, see if there's a value of lambda and mu such that we do in fact have a point of intersection. Okay? So if we look at our I values, then what will we get? 1 plus 5 lambda is equal to 17 plus 6 mu.
It's an I. That's a daughter.
If we look at our j values, then we have negative 2 plus lambda is equal to 4 plus 4 mu. Or sorry, what?
That's right.
Yeah. Yeah, 4 plus 4 mu. 4 plus 4 mu. I should have left some space in here. Actually, I'm going to go back to, I'm just going to solve this for lambda, right? So we're just going to go 5 lambda is equal to 16 plus 6 mu. And then we'll solve this one for lambda and get lambda is 6 plus 4 mu. Right?
I don't think.
And then we go to k, and we get 4 plus, thank you. Yeah, sorry, 4 minus 3 lambda
5 plus 7 mu.
is 5 plus 7 mu. Or let's go with 3 lambda, and we'll go with negative 1 minus 7 mu. Okay, yes, no, maybe so.
Yeah. Is that extra lambda? For J. Oh my god. 13 days.
So, as it turns out, using the equations for I and, do you plan on learning anything today? Like seriously, there's a lot of talking going on in here. Now I know you're all so familiar with vectors because my God, we cover them in English and we cover them in social studies so much that I know vectors up the wazoo that when this test hits me on, what day? Wednesday, that I'm going to be able to do this stuff because God knows I've been studying it for 9 years now. So hey, it's like algebra to me. Fine. Just seriously, shut your mind off and sit there quietly. All right, so look, I happen to have this, so I know what lambda is. So I'm going to stick it into here, right? So I'm going to solve this. I'm going to go 5 times 6 plus 4 mu is equal to 16 plus 6 mu, right? So we are substituting. We're solving a system by substitution because, you know, coincidentally, this just happened to solve for lambda. Makes life easy, right? I can do substitution. Otherwise, I would maybe have to do elimination or, you know, some other. You're just going to use your system solving skills. So what do we got? 14 mu, negative 14. So mu is negative 1. Yeah? I'm going to start making mistakes so you can catch them.
Okay.
On purpose this time, not just the usual mistakes that I make all the time. But
And then you say it's on purpose.
okay, so we are going to sub negative 1 for mu in where? L2?
What? I don't see an L.
Do you see L's there? In J. Okay, so lambda is equal to 6 plus 4 times negative 1. Lambda is equal to 2.
Ooh.
So we know that negative 1, 2 works in J, right? So you put a 2 in here, you put negative 1. Yeah, that's true. We know it works here. Well, we think it does. So I put a 2 in here. That's 12. 16 plus 12. Wait a sec. Put a 2. No, 2. 10. 16 minus 6 is 10. So it works in there. Here's the question. Does it work in here? Because if it does, then we have a point of intersection. And if it doesn't, then we don't. Okay? So that's why we've got these three equations. We only need two of them to solve, but that simply says that, hey, this system is solved by these. The question is this also? Okay? So we need to verify that, right? So we're going to substitute -1 for mu and 2 for lambda in K. So substitute -1 for mu and 2 in K. So what was K? K was 3 lambda is equal to 1 minus 7 mu. See if we get a true statement.
Or -1.
So -1. So lambda, we say 2. 3 times 2, is that equal to 1 minus
Minus
7 times -1? So 6 is equal to -1 plus. What did I do here? Where's my mistake? Yes.
It's minus 1.
-1. Yeah, see? Huh? Okay. Paying attention? 6 equals 6. Yes, it does. Okay, so then we know that they do in fact intersect, right? So let's do it. Happy face. Where is the point of intersection? Substitute into which one? Line 1 or line 2?
So it doesn't matter.
Doesn't matter, it's going to be the same point, right? So, which one's easier? To me, L1 looks easier, right? So the point of intersection. Okay, we'll go with line 1. And line 1 is 1, -2, 4. 1, -2, 4 plus, and line 1 used which variable? That used lambda, and lambda is 2, so plus 2 times, and the direction was 5, 1, -3. So 1 plus 10 is 11, -2 plus 2 is 0, and 4 minus 6 is -2. So the point of intersection is 11, 0, -2. The point of intersection,
P1.
11, 0, -2, right? Expressed as an ordered triple for a point in 3 space. Okay, so that's where they intersect. And same thing, you would have got the same thing if you'd have substituted, if you had substituted -1 for mu in equation 2, you would have got 11, 0, -2, right?
Unless you failed, comma. Yeah.
Yeah. No, that'll wait till Wednesday.
Oh.
Yeah. Angle between intersecting or skew. If they intersect or they are skew, there is an angle between them. Okay? And if they're skew, we just simply translate it down till, then we get an angle. And that angle is, well, what's the, how do we get angles? U dot W is equal to, we'll give you this formula. It's about the only formula we will give you. Okay, this is the formula you're going to get. U dot W is the magnitude of U times the magnitude of W cos theta.
What? Free advertising.
All right. Being as those lines intersect, let's just use the lines that we have. And what do we need from those lines?
Point of intersection.
No, not at all. Not even related. Not curious, not close. Totally different question. No. What's cos theta? Dot W.
Dot product, not cross product.
Fine, whatever.
Okay, what do we need out of U?
Magnitude
not the magnitude. Who cares? Line's infinitely long, so I don't know about magnitude.
Direction?
The only thing that matters is the direction vector, right?
Oh,
We don't care where the point is.
I paid attention.
Okay. All that matters is I got a line going in this direction, I got a line going in that direction, right? That don't intersect, but bring that. These do because we already found the point of intersection. But I could just bring this line into position, and then they intersect, right? But it's the dot product of the directions that matter, right? So, what's the direction of line 1?
4.
And what's the direction of line 2?
6, 4, 7.
Okay, so we're going to dot those together. And the magnitude of the first one is
5 squared.
negative 1 squared. Or sorry, 1 squared.
It doesn't matter.
Yeah, I understand. Well, it does because it's a 1. Plus negative 3 squared. And
6 squared, 4 squared.
6 squared plus 4 squared plus 7 squared. Okay. Equals. Let's do the calculation. What calculation do I do to get the dot product? What are the numbers I'm going to write?
5 times 6.
30
Plus 4.
plus 4
Minus 6.
minus 21.
Square root of
What do we got? 25, 26, 35?
Yeah. Yeah. So root 35.
36, 16. 52 plus 49. 101. Come on. It's all right. Use your calculators. Oh my God.
Guys.
Just keep in mind that you do have an exam, right? Paper 1, SL, HL, whatever, you know, flip a coin. No calculators, right? Now the numbers they give you are like this. The numbers they give you are relatively easy, right? I mean, literally, they just asked, here's vector A, here's vector B. What's A plus 3B? What's the magnitude of 2A minus B? Right? And there were 2D vectors, right? So,
Oh, they're not 3D vectors.
oh, they will ask about 3D vectors, but, you know, again, they're going to keep the numbers. They don't expect you to get the angle, right? Because you can't do the inverse cos of something, you know, unless it's an exact value, right? If you ended up with root 1 over root 2, then you know what the inverse cos. You should know what theta is, right? That's just knowing unit circle. You should know that. There's certain angles you must know. Therefore, if they ask you to find an angle on paper 1 where you have no calculator, then you have to know that, hey, that has to be an exact value.
Or maybe
Right.
maybe they give you like a trick if you get to
Okay, so theta,
those trick questions.
we don't need to simplify anything here. Well, I mean, we need 34 minus 21. So it's the cos inverse of 13 over root 35, root 101. Okay, you don't need to worry about root 35 or root 101 and reducing or anything. So what's theta?
77.37 degrees.
So 77, let's go with to the nearest tenth, 77.4 degrees. Okay, done.